In this video, I want to start the topic of logic circuits, more specifically combinational logic circuits. So a logic circuit has several components. We have usually some inputs, some output, a functional specification, and finally we have some timing specification. So generally speaking, if I want to draw a graph of a generic logic circuit, we have something like this. We have some inputs that usually are coming from left or top of the logic circuit, and then we have some outputs that are usually coming out of the logic circuit toward the right or toward the bottom. For this logic circuits, we have both functional specifications and timing specifications. So for the first few videos we only focus on functional specification, but at the end of the topic of combinational logic circuit you will see what I mean by timing specifications. So let's just take a look at this basic example. We have, for this circuit, we have some inputs. We have A, B, and C as the inputs. And as you can see, input A is connected to E1 and E2. Input B is connected to E1 and E3. And input C is only connected to E2. The outputs of E2 and E1 are connected to E3 along with B. And then finally we have two outputs for this generic circuit. One comes out of E3 and one is basically coming out of E2. So if I want to list all the nodes, we have the inputs, we have the outputs, and we have some internal nodes. So to see what I mean by node, consider a node as a wire in your circuit. So these two wires, this one and this one, since they are both carrying A, it is considered as one node. This wire, for example, since only carries C, it is considered as only one node. So based on this, we have three input nodes, we have two output nodes, and there is one single wire that we didn't account for using inputs and outputs, which is this wire that connects the output of E1 to the input of E3, and that is the internal node. Here we call it N1, for example. As for the circuit elements, we have E1, E2, and E3, and each one of these elements can themselves be a separate circuit too. So there is nothing against having internal logic circuit inside a larger logic circuit. So now that we saw this, let's just see what are the different types of logic circuit that we can have. There are two major types of logic circuit that we can have. The first type is the combinational logic circuit, and the second type is the sequential logic circuit. The combinational logic circuits are memoryless, which basically means that whatever you provide as the input, the inputs contribute to create the final output. So in another word, the outputs are calculated or determined by the current values of the inputs. So there is no sense of memory. What happened before doesn't affect what happens next, right? At any given moment, whatever input that we have, the output is determined by the input at that exact moment. On the other hand, sequential logic circuits, they have memory, which basically means that the output for these circuits are determined by the previous and current values of inputs. So for example, an example of a sequential logic circuit is a clock, right? So you need to know what was the time before to know what is the time next, right? Uh, Without the time before, you don't know what is the next time, right? So that is the main difference between combinational logic circuit and sequential logic circuit. Of course, when we get to sequential logic circuit, I will go into much more detail about the subtle differences that we can have between different types of sequential logic circuits too. But generally speaking, the generic representation is still the same for both of them. So this function can be either a combinational logic or sequential logic circuit. The generic description doesn't change. We still have some input and we have some output. The way that these inputs and outputs are connected inside this logic circuit basically determines whether we are dealing with a combinational logic circuit or a sequential logic circuit. So now that we saw the two types of logic circuits, let me start the very basic properties of combinational logic circuit. So for any combinational logic circuit, we have some basic rules that need to be satisfied. The first one states that every element in a combinational logic circuit should be combinational itself. So remember, any combinational logic circuit was a memoryless logic circuit. So it's only natural to have all the components to be also memoryless too. So that is what this first rule states. The second one states that every node is either an input or connects to exactly one output. So for example, in this basic circuit, you cannot have, let's say, multiple outputs with different names, so X, Y, and Z. Since they are all connected to the same output of this circuit, they all have exactly the same name, right? So this is what the second part of this rule specifies. And finally, the last rule, the circuit should not contain any cyclic path. So again, let's just take a look at this example. We cannot have such thing in our circuit. So there shouldn't be any connection between the output of a circuit and the input. Or there shouldn't be any loop. Basically, as you can see here, we have a loop here. This is something that is not allowed in combinational logic circuits. It is allowed in sequential logic circuit, of course with some conditions, but for combinational logic circuit there shouldn't be any cyclic path of this sort. So in this video we have learned the basic components of a generic logic circuit. We saw the two types of logic circuit, combinational logic circuits and sequential logic circuit. And finally we saw the rules that apply to combinational logic circuits.